everybody. Today we're going to learn how to separate a mixture. So in the previous lesson we learned what a homogeneous and a heterogeneous mixture were, and now we're going to learn the strategies that exist to separate them. So let's go ahead and start out with a small little list that shows 5 of the ways we can do that. First we see distillation, then we see evaporation, precipitation, filtration, and chromatography. And to that list, we can also add a few more that we'll just throw in here, considered manual or manually, magnetic, and something called centrifugation. So I'm actually going to start with what's inside of the green box here as we look at manual separation, magnetic, and centrifugation. So first, manually is just what it sounds like. You're actually going to go through and through visual observation be able to pull apart. In this case, we have basically a random assortment of different nuts, and we can pull them into their own separate piles and separate this heterogeneous mixture. Next, we can take a look at a heterogeneous mixture of chalk and iron filings. And you can see someone has put a very large and powerful magnet into the end of that pile, and they're currently separating out the iron filings due to its magnetic properties from the chalk dust. The last one we're going to take a look at is what we call centrifugation. So centrifugation is done for things like solutions that need to be separated by density on the inside. And the example that you see here is someone has lanced someone's finger, which has filled a centrifugation tube up with blood. So what's going to happen is we're now going to take that blood and we're going to put it inside of a test tube and spin it very quickly. And what's going to happen is the heavy stuff that is inside of blood, the cells, both red blood cells and white blood cells and platelets, by centrifugal force, they're going to wind up moving down to the bottom of the tube, and the lighter stuff is going to wind up on top. So by the time you're done spinning a blood sample, what we have is a dark portion in the bottom half of the tube and then a yellowish looking color at the top part of the tube. And that's because all the heavy stuff went to the bottom, and it's dark red because it's full of red blood cells. Meanwhile, the yellow portion that we have after spinning it is going to be from what we call plasma, which is a light yellowish type of color, and it's a transparent fluid that has a lot of ions floating in it. So I'm going to give you a look at what a real centrifuge looks like and how one is used, and we'll pop that open now. So this is what we call a centrifuge. As you can see, it's a cylindrical machine, and what we do is we just flip a switch on it, and what we're going to see happen is this rotor on the top is going to start spinning very, very quickly, hundreds and up to thousands of revolutions per minute. So if I have something like this, a couple of samples that I need to spin down, what I'm going to do is I'm going to go ahead and I'm going to load them in the tubes that you see there. You also see that they're numbered 1 through 6. So I want to make sure that any tube that I spin has a counterbalance on the other side, so it's evenly balanced and it spins properly. So I'm going to choose tubes number 1 and number 4, and I'm going to go ahead, I'm going to turn it on, and what you can see is that it's now spinning, and it's going to start spinning faster and faster. You might be able to pick up some of the sound that comes from it. And what happens is the heavy stuff inside the tube is going to go to the bottom, and meanwhile the light stuff on the tube is going to go to the top. So in other words, we're separating a solution. Usually they're homogeneous solutions. So you just saw the example with the blood, but I had a couple of different samples in there, and what I can do now is I can take out the tubes and I can analyze my sample to see what has sunk to the bottom and what has floated to the top. And that's centrifugation. So onto our major list of ways to separate mixtures. Here we have a beaker that has some kind of orange fluid in it, and it seems to have like little black specks that are kind of spread throughout the solution. Now, what you see happening is someone is pouring this solution down, in this case it's a stirring rod, to allow it to fall into this thing right here, which is a filter. So the filter itself is lined, the filter funnel is lined with filter paper. So what we have is a hard case on the outside here, and we have a filter paper very much like a coffee filter that sits on the inside. And that coffee filter or filter paper has tiny little holes, but the holes are not so tiny as to nothing will go through. They're large enough to let the orange fluid actually pass through their holes. But what they're small enough for is to catch the little black specks that you can see spread throughout this particular solution. What we get out of here down below is what we call filtrate. And filtrate, there we go, there's filtrate. Filtrate is the fluid that has now been cleaned up of its impurity. As you notice, there's no black specks here in the filtrate. Instead, it's a much cleaner orange fluid. Now, the name of this process, of course, is filtration, if you haven't figured that out yet. And it's a method for separating components of a mixture containing a solid and a liquid using a porous barrier, which means that it has holes in it. If you ever make coffee, this is the same procedure that allows you to brew up a cup of coffee. The coffee grounds are trapped in the filter, and meanwhile the filtrate, the part you enjoy, is actually the coffee that you're going to drink. The next strategy on the list is the process of vaporizing a liquid followed by condensation. So this one here is kind of a two-parter. So we have vaporization and then condensation of what starts out as a liquid sample but eventually turns into a vapor, and then at the end comes back to a liquid again. So initially down here we can see that we have some kind of cloudy orange type of solution, and we can see that it's currently in this unit, and this is going to boil whatever solution you have in this round bottom flask, and you can see that the liquid is changing into a vapor and it's going up this way. Well, the only place for that vapor to go is up this tube here and then take a quick right turn and go down this tube here. Now, this is a glass apparatus right here, so this cylindrical looking tube with a hole down the center is going to collect the steam and turn it into a liquid. Now, how does it do that? Well, it does so because we have cold water that's flowing through this hollow glass tube, and that cold water is going to cool down this vapor right here until it condenses into a liquid. That's what the condensation part is right here. The vaporization part happens right here. And what we have coming down and rolling down the glass tube then is a much cleaner version of this fluid here because it boiled off. And whatever impurities that are left inside of this round bottom flask will be the only thing left when you're done with this process. So the liquid then, much cleaned up, is now the filtrate in this flask down here, the collection flask. And this process here is called distillation. If you want to take a look at what the real process looks like, I'll move the slide ahead to here, where you can see what you'll actually be doing a little bit. If you take college level chemistry, you'll be setting up a distillation setup like this one, using a Bunsen burner as your heat source. You have salt water in a round bottom flask, and what they're doing is they're purifying this water so it's no longer salt water. So the water is going to wind up boiling off into a vapor. It's going to come up this way, take a right hand turn, and here we have cool water entering the glass tube. It's going to move that way. I should probably use blue for cool water. There we go. And it's going to change the gas, which is now coming down this way, into droplets by condensing them. So eventually those droplets we saw in the previous diagram are going to roll out of this tube and they're going to enter this receiving flask down here, and now we have pure water. The only thing that's going to be left in this round bottom flask here is going to be the salt that's left over. The last two types of separation strategies we'll look at. The first one is going to be called crystallization, and crystallization is going to happen by forming solid crystals from a homogeneous mixture. So later on when you study solutions, you're going to find out that some solutions are considered supersaturated. That means that someone heated them up so much that they were able to put more dissolved solute or more dissolved particles in them than that particular solution should be able to hold. So then what happens is, through a stimulus that you're able to provide for this solution, you can cause all the extra crystals that aren't supposed to be in there, the ones we said that are too much, to come back out of solution. And they usually do so in a very elaborate way. So you can see some really cool looking crystals in this test tube. And right now I want to show you a video of a solution that's actively what we call crashing out. So all of the extra solute or dissolved particles in there come out very, very quickly. We'll show you that right now. So what we typically see happening is that stimulus I was talking about, the thing that can get a solution to crash out, is usually what we call a seed crystal, which means you take, once this solution has cooled off, we take a seed crystal of the same compound that's super saturating that solution, we drop it in the top, and that can be enough to have all of the extra suddenly come out of solution once again. Now, the other way that you can do it is sometimes do a little bit of an impact to the side of the glass. So once the solution has cooled off, you take something like a glass stirring rod, you give it a little bump to the side of the test tube in this case, and that will be a stimulus that's plenty enough to have that solution come out, crash out of solution, we call it. Now, the last type of separation technique we have is where we separate small amounts of substances from mixtures by the rates at which they move through or along a medium. And that process is called chromatography. If we have something like a black ink spot on a piece of filter paper, what we're going to do then is we're going to allow that filter paper to reach the surface of the water, and that's going to be enough to draw water upward, up the paper, right past the ink spot. As it hits the ink spot, what's going to happen is the ink pigments that are least attracted to water in the filter paper, they're going to move really quickly. So in this case, our black ink has a blue pigment running faster than the other two, which means that it doesn't like the water very much because it's running away from it, and it doesn't like the paper very much, so it's on the move. Meanwhile, the second pigment, the red pigment, doesn't really like it either that much, but it doesn't have a hatred as much for the water and for the paper as the blue does. So it's still going to be on the move, but not quite as far as the blue pigment, so they're going to separate from each other. The last pigment, the yellow pigment that we see down here, it doesn't mind water so much, nor does it really mind the paper. It actually kind of likes the paper, so it doesn't travel too far from the actual ink spot. And that means that it's not going to move very far up the paper whatsoever. It's just going to kind of hang safe at the bottom near the ink spot. But what we've done then is we have visually separated all the things that make up black ink in a marker. So we can see there's 3 separate pigments, and we know a little bit about their chemical properties of attraction for water and attraction for paper as well. Now, the only one we didn't mention was evaporation, and hopefully we all have a fairly good background knowledge of that, where we basically just have water in some kind of container, and over time, molecules from the atmosphere bump into it, and the H2O goes from the liquid state to the gas state. So I hope you understand separating mixtures a little bit better now. We can separate heterogeneous mixtures and homogeneous mixtures by nothing more than physical means, sometimes using a little bit of scientific equipment, and sometimes as simple as using our eyes to separate something by hand. So that's separation of mixtures, and I'll catch you guys next time. See ya.